company with just 2 employees, Sanjit and Patel, rents a floor of a building with 12 offices. How many ways there are to assign different offices to these 2 employees? Which means someone build a new building. In that building, there we have 12 shops. 12 shops. So we are someone build a building with 12 shops. 12 shops. Okay. So they okay. So here, so we are having 12 shops. Let me get my new board. Yeah. Okay. So I'm having 12 shops. So 12 shops I'm having. Can you all see my screen? Are you able to see my screen that I don't know?
Yes, ma'am.
Yeah. So I'm having 12 shops. The 12 shops are there. Okay. So these 12 shops are empty. The 12 shops are empty. Okay. So they want to give the rent for this 12 shop. Okay. So the first Sanjit came for this 12 shop. So Sanjit have 12 options. They can choose any one of this shop. Am I right? So Sanjit have 12 options. So suppose if Sanjit take this, so this shop means, okay, so Sanjit take this shop. So Sanjit has how many possible? 12 possible, because they are having 12 shops. So they can choose any one of these 12 shops. Okay, they can take rent, they can take shop, any one of these shops for what is it for?
Sanjit.
Sanjit take any Sanjit has 12 possible. Okay, he can take any one of these stuff. Okay, so Sanjit has 12 possible. So next Pradeep Patel, who is someone else. So Pradeep come for searching for another shop. So they have 11 possible. They are having 11 possible. So in that 11 store only, they can choose any one of these store. Am I right? Suppose if Patel take this shop means, so Patel has 11 possible. So totally Sanjit and Patel both are have 132 possibles. Both are having 132 possibles. Is it okay, girls? Okay. Now see my question 1. What's my question? A new company with just 2 employees. If they are having 2 employees, Sanjit and Patel, rents a floor of a building with 12 offices. Okay, so we are having 12 offices. Okay, so we try to begin a new company. New company means, so Sanjit first came Sanjit. So Sanjit have 12 possibles because we are having 12 office. In a building we are having 12 office. So they can choose any one of this office from the 12 office. So Sanjit has 12 possible. Okay, so next come for Patel. So if Sanjit take any one of this 12 shop means, Patel has only 11 possible. In the 11 office, he can choose any one of this office. Okay, so Sanjit has 12 possible. So and Patel has 11 possible. So totally we are having 132 possibles. Is it okay, girls? Tell me.
Ma'am.
Who is that? Tell me, ma'am.
Swarna Prasanna.
Swarna and Afroz Prasanna. 46 again. Why are you coming late? 15 minutes late, Swarna.
Ma'am.
So you are late for 15 minutes. Why?
Ma'am, network problem, ma'am.
Yeah. Yes, is it clear? The first question is clear? Okay, Shwarna.
Yes, ma'am.
Shall I go to the next problem? Yeah. Now read the next problem. The next problem is, the chair of an auditorium are to be labeled with a letter and a positive integer. Okay, not exceeding 100. So the chair of an auditorium. So in auditorium we are having chair. So that we are labeled the chair. Okay. So we are labeling the chair with both letter as well as integer value. Positive integer 1, 2, 3, etc. Positive integer not exceeding 100. So we can write the integer up to 1, 2, 3 up to 100. Okay. And what is the largest number of chairs that can be labeled differently? Okay, we have so many chairs. Okay, so I do this problem. Okay, suppose we have to name like this. The first chair is we have to name A1. The second chair you have to mark it as A2. The third chair you can mark it as A3. So up to we can choose for A100. Okay, because we can choose up to the integer value 100. Okay, so we can label the chair starting with 1 and end with 100. Okay, with some letter. So I'm having the same letter A1, A2, A3, A100. So next chair I'm taking as B1, B2 up to B100. Okay, so on the third row I can place it as C1, C2 up to C100. So up to this I can write Z1, Z2 up to Z100. Is it clear, girls? Can you all see my screen? Is it?
Yes, ma'am.
Yeah. So I can label like this. Okay. So after finishing that, you can start with A1, A2 up to A100. But these are all the different labels. So how many labels are there? So here I'm having 100 columns and 26 rows. Am I right? So 26 into 100 possibles. 26 into 100 possibles. Because for integer you take up to 1 to 100. And for letters, I'm having 26 letters. A, B, C, D up to 26 letters. So we are the possible labeled chairs are 26 into 100. That is 2,600. Is it clear? Is it clear, ma'am?
Yes, ma'am. Yes, ma'am.
Yeah. What about others? Others, is it clear?
Yes, ma'am.
Yeah. Okay, guys. And now come to my third problem. What is my third problem? There are 32 microcomputers in a computer center. There are 32 microcomputers in a computer center. Okay. Each microcomputer has 24 ports. Each microcomputer has 24 ports. So how many different ports to a microcomputer in a center are there? How many different ports of microcomputer in a center are there? So 32 computers, 32 computers, each computer has 24 ports. Okay, each computer has 24 ports. How to do this one? Okay, so we are having 22 computers. 1, 2, so these are the computers. 3, 4, up to we are having 32 computers. I'm having 24 ports. 24 port 1, 2, 3, up to 24 ports are there. Okay, so the first computer can have any one of these 24 ports. Any one of these 24 ports. Second is also having any one of these 24 ports. Third is also having any one of these 24 ports. Is it okay, girls? So that is also having any one of these 24 ports. Okay, so I'm having 32 computers. Okay, so each one, 32 computers, each one having ports. So 24 ports. So this is a quadratic tool. 32 into 24. Is it okay, girls? Now read that question again. So there are 32 microcomputers in a computer center. Each microcomputer has 24 ports. Okay. So what's the solution? And the procedure of choosing port consisting of two tasks. The first picking a microcomputer and then picking a port of this microcomputer. Okay. So because there are 32 ways to choose the microcomputer and 24 ways to choose the port. Is it okay?
Ma'am?
So no matter. Yeah, tell me.
Ma'am, we have to start the recording, ma'am.
Not recording. Thank you.
Welcome, ma'am.
Yeah, okay. Yeah. So we have 32 possibles, which means here we can choose if we are having 32 computers. So we can choose suppose if we are taking 32, we can taking the 32 computer, 32 microcomputer, and we can connect the port with 3. Is it okay, guys? So whichever way we can connect, we can select any 2 32 computers. Okay, so we have 32 possibles here. Also here I'm having 24 port. Here I'm having 24 port. Is it okay? Some people will be removed from the meeting. Yeah. Okay. Is it okay, guys? Is it clear? Shall I go to the next problem?
Yes,
Fourth
ma'am.
problem?
Yes, ma'am.
Yeah, fourth problem is very easy. How many different bits? Yeah, tell me.
Recording has been stopped, ma'am.
அதான் யாரும் ஸ்டாப் பண்ணிருக்காங்களா? நம்மளோட ஸ்டாப்பிங். அதான் எனக்கு ஒரு மெசேஜ். ஓகேமா, தேங்க்யூ. The record will be start soon. Yeah, okay. So the next problem is how many different bit string of length 7 are there? What is bit string? How many bit string are there? Bit string is nothing but either 0 or 1. Bit string is nothing but either 0 or 1. So what is my question is how many ways you can write this 7 bit? 7 bit is nothing but we have 7 digits. We have 7 digits.
This
So we
call
are
is now
having
being recorded.
7 digits. Okay, we are having 7 digits. So how many possible way we are having 7 digit bit value? Which means in the first one, we can put either 0 or 1. So in the first one we have 2 possible. We can put either 0 or 1. The second also we are having 2 possible. We can put either 0 or 1. The bit value is nothing but either 0 or 1. The third is also we have 2 possible. 4 is also we have 2 possible. 5 2 possible. 6 2 possible. 7 digit also we have 2 possible. Either you can put 0 or 1. Here you can put 0 or 1. Here you can put 0 or 1. Here you can put 0 or 1. 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 So we have how many possible? How many ways? 2 into 2 into 2 into 2 into 2 into 2. That is 2 power 7 ways. So we have 2 power 7 ways. Is it okay, guys? Is it clear?
Yes, ma'am.
Solution. So how many different bit string of length 7 are there? Each of 7 bits can be chosen in 2 ways because each bit is either 0 or 1. So each 7 bit you can choose in 2 ways, either 0 or 1. So therefore, using product rule, what is the value? 2 power 7. 2 into 2 into 2 into 2. That is 2 power 7. Is it okay, girls? Yeah. Now come to my next problem. So read the third problem. The third problem, how many different license plates are available? How many different license plates are available? If each plate contains a sequence of 3 letters followed by 3 digits. So முதல்ல 3 letter and followed by 3 digits. So we are having 6 letters, 6 words. And no sequence of letter are prohibited. Okay, even they are absent. Okay, right. Okay, so we are having 6-letter number pair. 6-letter number pair. 6-letter number pair. Okay, so what's your question? The first three number plate contains the digit letter. The last three containing the numbers. Okay, so numbers means it starts from it starts from 0 to 9. Am I right? Here I'm having either 0 or 1 or 2 or 3, whatever it may be. Here I'm having either 0 or 1 or 2 or whatever maybe I'm having here. So here also I'm having 0, 1, 2, 3 up to 9. Here also we have 9 possible. Okay. In each one we are having 9 written. Start with 0. Start with 0 means it has 10 possible. It has 10 possible. Okay, so each one has the 10 possible. The last three number plate has the 10 possibles because here we are having either 0 or 1 or 2 or 3. Okay, so here I am having either 1 or 0 or 2 or 3 or 4, 5, 6, 7, 8, 9. Okay, so we are having 10 possible here. So here also you are having 10 possible. So here also you are having 10 possible. Here also you are having 10 possibles. Is it okay, guys? So we are having 10 possible in the last 3 digits in the number plate, and in the first three are having letters. Letters means how many letters are there in alphabet? 26 letters. So in the first number plate, the first letter we are having 26 possible. Second one we are having 26 possible. Third is also we are having 26 possible. Is it okay? Either you can have the first one, either you can have A or B or C or D, whatever maybe you can have. B also either you can have A, B, C, whatever maybe you can have. Okay, whatever maybe you can have that one. Okay. So how many possible finally? 26 into 26 into 26 into 10 into 10 into 10. Am I right? So these are all the possible of 6-word number digit. Is it clear?
Yes, ma'am.
Yeah, good. That is my see the answer. There are 26 choice for each of the 3 letters and 10 choice for each of the 3 digits. So finally the answer is 26, 26, 26, 10 into 10 into 10. Okay. Next problem. How many functions are there from a set with m elements to a set with n elements? How many functions? Okay, do this one. What's my question? How many functions? Suppose my function is f from a to b. This is my function. What is my question? I can see that again. Functions from a set with m elements to n elements. A set with m elements to n elements means, suppose I consider the function a to b. So A contains m elements. A contains m elements and B contains n elements. That is my question. Okay. That is a function from m elements to n elements. M elements to n elements. So I am taking the two set A and B. So A contains m elements and B contains n elements. Okay. And what are the possible ways of defining a function? Which means you can draw that. Suppose, for example, instead of m, I'm having here some 4. Here I'm having some 5. Whatever may be small, I'm having them. Okay, so I'm having 4 elements here. 1, 2, 3, 4. I'm having 5 elements in the codomain. B. A, B, C, D, E. I'm having 5 elements here. Okay, so what are the possible names? One is mapped to either A, B, C, D, E. Am I right? A mapped to either A, B, C, D, E. Am I right? So one have 5 possible. One have how many possible? 5 possible. The first element have 5 possible. What about 2? We can suppose if 1 is mapped to A means 2 is also A mapped to A. Is it possible? Is it a function? Okay. So 2 is also having 5 possible. 2 is also mapped to either A or B or C or D or E. So 2 is also having 5 possible. Is it okay, girls? Similarly,
Yes,
3 is also mapped to either A or B or C or D. The same elements can be mapped. That is also a function. Okay. Is it okay? So 3 also having 5 possible. And 4 also having 5 possible. So each element of domain has number of each element of domain has number of element of codomain possibles. Okay, so I can write 5 into 5 into 5 into 5 as 5 power 4. What is my 5? 5 is number of element of codomain. What is my 4? Number of element of A, that is domain. So from my problem, I can conclude that. Okay, from my problem, I can conclude that. Okay, so B having codomain having n elements, so n power m. So my possible ways of my given problem is n power m. So please note this example. Here the codomain is 5. This is my codomain. So my codomain is 5. My codomain is 5 and domain has 4 elements. Domain has 4 elements. Am I right? So codomain has 5 elements and domain has 4 elements. So the answer is 5 power 4. Codomain, number of elements of codomain power number of elements of domain. Okay. In my problem, in codomain have n elements. And domain has m elements. So my answer is number of possibles n power m. Is it okay, guys? Is it okay?
Yes, ma'am.
Yeah, okay. The next problem is can you see the problem? See the solution of sixth problem. A function corresponds to a choice of one of the n elements in the codomain for each of m elements in the domain. So the product rules n into n in each one having அது வந்து 5 into 5 into 5 into 5 வந்து 4 times. Here n வந்து m times. So n power m. Sorry first. Wait a minute. Yeah. Is it okay? Is it okay, girls?
Yes, ma'am.
Yes, ma'am. Yeah, okay. So come to this seventh problem. One-to-one function. How many one-to-one function are there from a set m elements to n elements? Here, in the sixth problem, just I'm having a function. The function may be whatever may be that function. Okay, but here the seventh problem specify that it's a one-to-one function. What is one-to-one function? What is one-to-one function? What's the meaning of one-to-one function? Means each domain has unique pre-image. Each domain has unique pre-image. Is it okay? Suppose again I'm taking my function f from a to b. In the problem given that a has m elements, b has n elements. A has m elements, b has n elements. Suppose if I take f from a to b. Suppose if I am having a has 5 elements, b has 4 elements. What happens? The logic figure, a has 5 elements. Suppose I am taking 1, 2, 3, 4, 5. I am having 5 elements here. Suppose if I am having 4 element means, suppose 1 is mapped to A, 2 is mapped to B, 3 is mapped to B, 4 is mapped to B. I'm having the another element 5. So 5 is mapped to any one of these. Suppose I take 5 is mapped to B, which means my 5 and 2 have the same image B. 5 and 2 have the same image B. So this is not a one-to-one function. What is the meaning of one-to-one function? One-to-one function means each element of domain has the unique pre-image, unique image in the codomain. Unique image is the one-to-one function. So this is not one-to-one function. So from that what I can conclude is the one-to-one function is possible only the one-to-one function is possible only the number of elements of A should be less than the number of elements of B. So the one-to-one less than or equal to whatever means. Okay. So the one-to-one function is possible when M is less than or equal to N. If M is greater than N means one-to-one function is not exist. One-to-one function is not exist. Is it okay, girls? Is it okay?
Yes, ma'am.
Yeah. So the one-to-one function is exist when M should be less than or equal to N. Okay. So I can take M is less than or equal to N. Suppose if I take M is less than or equal to N. So M is less than or equal to N. So my function is A to B means A has M elements, B has N elements. Okay, suppose if possible I'm taking A has 4 elements and B has 5 elements. If I'm taking A has 1 element and B has 5 elements. Okay, because here M is less than or equal to N. So A has 4 elements means what can I get? So suppose I'm having here 4 elements A, B, C, D. So here I'm having 5 elements 1, 2, 3, 4, 5 means. Suppose, so what can I do is A is mapped to. A is mapped to any one of these 5. A is mapped to either 1. A is mapped to either 1. A is mapped to either 1 or 2 or 3 or 4 or 5. So A has 5 possible. Suppose if I take my A is mapped to 2. If A has 5 possible, A can map to any one of these 5. Suppose if I take A is mapped to 2. What about B? Now B can't map to 2 because this is a one-to-one function. One-to-one function means each element has a unique image. Each element has a unique image. If I map B to 2 means and A and B have the same image arrow. That is not possible because this is a one-to-one function. So B has 4 possible only. B mapped to either 1 or 3 or 4 or 5. B mapped to either 1 or 3 or 4 or 5. So B has only 4 possible. B has only 4 possible. So suppose if I can say B is mapped to 1. Is it okay, guys? So B has only 4 possible. Similar come to C. What about C? C can't map to either 1 or 2. Because A and B are mapped to 1 and 2. So C is mapped to either 1 or 2 means that is not one-to-one function. One-to-one function means each domain has a unique image. Okay. So C has 3 possible. C is mapped to either 3, 4, 5. Suppose I take C is mapped to 5. C has 3 possible. C mapped to either 3 or 4 or 5. Is it okay, guys? Now come to D. So D has now 2 possible, 3 and 4. D has 2 possible, 3 and 4. Is it okay, girls? Is it okay? So this is
Yes,
the
ma'am.
possible ways. So possible ways. 5 into 4 into 3 into 2. What is my 5? It starts from the element codomain. What is my codomain? N. So from that I conclude that the possible ways are n minus 1. It decreasing by 1, 1, 1. 5, 4, 3, 2, 1. So n minus 1, n minus 2 up to n minus m minus n. I write it in the next page. Okay, so the possible ways is n minus 1, n minus 2 up to n minus m minus n. Is it okay, girls? N minus m multiple. Is it clear? If it is a function, if it is a normal function means The possible way is n power m. The number of element of codomain power number of element of domain. That is the way. That is my sixth question. In the seventh question is what my seventh question is? It is a one-to-one function. One-to-one function is if the first element is mapped to one image, one element image, then the second element can't be mapped to that the same number. Because this is a one-to-one function. One-to-one function means each domain has a unique domain has a unique image. Is it okay? So the possible way is n minus 1, n minus 2 up to n minus m minus 1. Is it okay? Clear? Is it okay, guys? Okay. Now shall I go to the eighth problem? Is it clear for you? Because these problems are very big problems. That's why I can't write it in the note. Is it clear? This method is working for you?
Yes, ma'am. It's okay, ma'am.
Yeah. Now this eighth problem is the telephone numbering plan. Telephone numbering plan. What's my question? The format of telephone number in North America is specified by a numeric plan. A telephone number consists of 10 digits. 10 digit. They are all split into 3 digits. 3 digit in the area code, 3 digit in the office code, and 4 digit in the station code. What's the 10 digit telephone number? The first 3 digit contains the area code. Next 3 contains the office code, and last 4 contains the station code. So like that, our telephone number are there. Okay. So because of signaling format, X denotes the digit that can take any of these values of 0 to 9. So X denotes 0 to 9 and N denotes the digit that takes the value from 2 to 9. So X denotes the number 0 to 9, N denotes the digit வந்து 2 to 9. Note பண்ணிக்கோங்க. And Y denotes the digit 0 to 0 or 1. Two numbering plan which will be called the old plan and new plan. So we are having 2 plans, old plan and new plan will be discussed in the problem. Okay. Old plan. Okay. So now come to the last para. In the old plan, the format of area code, office code and station code are NYX, NNX, XXX, 4X. Okay. New plan code. So the old plan for NYX hyphen NNX hyphen 4X. Okay. And then the new plan code NXX 4X. Okay. So what is my X denote? What is my X denote? X denotes a digit from 0 to 9. The problem given. And Y denotes the digit 2 to 9. அப்புறம் என்ன கொடுத்தாங்க X Z என்ன N denotes the digit 2 to 9. Y denotes the digit either 0 or 1. So these are the given one. Okay. And what is my old plan? Old plan is what's my old plan code? Old plan code is NYX, NNX, XXX. NYX, NNX, XXX. Okay. So old plan code is NYX, NNX, XXX. So this is my old plan code. So first you have to find NYX. So what is NYX possible? NYX is possible as how many possible for N? How many possible for N? 2, 3, 4, 5, 6, 7, 8, 9. 8 possible for N. Into how many possible for Y? Y has
Two, ma'am.
2, either 2 or 1. into what is my x? X has 10 possible. So how many possibles of NYX? 160. Yeah, 160. Okay, so for the first 3 digit, I'm having 160 possible. First 3 digit NYX, I'm having 160 possible. Now come to second 3 digit. In the second 3 digit, the second 3 digit is what is that? NXX. NXX means NXX.
NX, ma'am.
NNX. The NNX means N has how many possible? 8 possible. Again, N has 8 possible. Into X has 10 possible. So 640 possible. Okay. And last 4 digit is I am having 4X. 4X means each X has 10 possible. 10 into 10 into 10 into 10. 410. So 10,000 possible. So finally, how many possible for the old number? What is my old number? My old number is NYX hyphen NNX hyphen XXX. So possible ways are 160. First 3 I'm having 160 possible. NNX I'm having 640 possible. And XXX I'm having 10,000 possibles. So multiply those 6, we can get the answer. So this is the number of possibles for my old plan. Okay. What is my new plan code? New plan code is NXX, NXX, XXX. So NXX, NXX. So my new plan code is NXX, NXX, XXXX. So this is my new plan code. So what is the possible for NXX? NXX possible is, for N I am having how many possible? 8 possible. X is 10 possible. Am I right? So 800 possible. So similarly I am having NXX. For XXX I am having 10,000 possible. So for new planets, how many possibles are there? So for NXX I am having first 3 digit I am having 800 possible. Second 3 digit I am having 800 possible. And last 4 digit I am having 10,000 possibles. So these are the possible ways of new plan. Is it okay, girls?
Yes, ma'am.
Yeah, am I right? Yeah, right. What's the time now? I think the time's up.
Ma'am, still 2 minutes more.
Can we do one more problem? What can you do? 35 only present. The approach and corner present. Okay. We have some more. The section I'm going to mention. Just I'm explaining only 2 pages. Shall we go to the next one? What can I do? So okay, I'm doing it in the next class. Yeah. Now tell me your feedback. What about this method is working?
Yes, ma'am. It's easy to understand, ma'am.
Yeah. Okay. Because so these are very easiest to follow. That's why I send the PDF. I send this PDF. Okay, you can just read it. You can easily understand these problems. Is it okay, guys? Okay, then you can leave now. Thank you.
Thank you, ma'am.
Okay, guys. Company